Hi everyone, welcome to week 5. Let's talk about color theory for print. In this module, we've got a couple little presentations and some test your knowledge. Here's a PDF that I'd like you to download. This is the presentation I'm going to walk you through right now. Once you get into that screen, let me just pop ourselves into full screen. We're going to talk about the difference between color for working on your screen and color for print. We're going to talk about something called additive and subtractive color models, Pantone matching system, rich black, and ink limits. So additive and subtractive color models, additive color models being your RGB, it's based on luminance, so it's based on light being projected to create the colors. And you notice here that if we have RGB, you've got as the red and green overlap, you get the yellow. If you get the blue and the red, you get the magenta. But if you combine all three blends, you will end up with a white, a pure white. Now versus a subtractive color model being CMYK. The K is actually key black, and it was created to create a richness in black, because if you just combine magenta, cyan, and yellow, you end up with a kind of a brown, muddy mess. So that's where key, or the K, comes from. But if you think about these two models, so additive being adding light, the subtractive is you're subtracting light. You're actually putting ink down on a substrate, whether that's paper or glass or metal or whatever that happens to be. You no longer have light to reflect the color. So RGB is made up of 3 colors. This is our additive color model. It is based on a light system. As the colors overlay, they create different lights. Then we have our process colors, also known as 4-color. This is a subtractive color model, the cyan, magenta, yellow, and key black. Again, this subtractive color model is based on the subtraction of light. And if you were to put ink down on paper, you will see that it results in a much darker color. So RGB color formats are RGB, so 100% red. So you have 3 lenses. You have a red, a green, and a blue lens. And if you want that value, so your color range is from 0 to 255. So to get pure red, 255 is your value. Pure green, 255 for green, and 255 for blue. If you want white, again, combining all of those colors, 255 for all 3 colors will give you pure white. 0 will give you black. CMYK colors. So you have your cyan, magenta, yellow, and black. To get the brightest color you can get in CMYK format, combining 2 inks minus black. So in this case, 100% magenta, 100% yellow will give you the brightest red you can get for print. This is an interesting diagram because it actually talks to the back circle, outermost circle, is what we see with our eyes. The next layer inside, this is the RGB. So this is what we're seeing through our telephones or any digital devices, our monitors, scanners. The next level in is called something called Pantone color, or Pantone matching system, PMS. And this color is a subtractive color model. It is meant to enhance CMYK. You can see this small little rectangle, or triangle on the top. This triangle represents CMYK coverage. So this is what CMYK can create. Now, if you want a really vibrant green or a super vibrant blue that you're seeing on the screen, when you try to print that, you're not going to get that reproduction. That's when Pantone pops in, and you would pay for that additional ink. So consider going to the hardware store and you want a color swatch to paint your wall, and you've chosen the color swatch you want, and they give you a tin of paint. That's exactly the same process for Pantone matching system. What they do is, based on a number system, they will create a tin of ink, and that will go on the press to complement the CMYK run. And then it would actually enhance the color. So you can get the brighter reds and the oranges that you just can't reproduce simply with using CMYK. So again, really super important to understand that these top two layers are subtractive colored monols. The bottom ones are additive. So again, using light. Your Pantone matching system, this is what a swatch looks like. This is also known as a spot color. And you can see these numbers here, and these numbers, the U represents the actual paper that it's going to print on. So this is an uncoated paper. We're going to learn about paper in the next couple coming modules. But there is a coated and an uncoated paper. In an uncoated paper, this is what the colors will look like if you key in these numbers to be the color that you're looking for. So spot color versus CMYK, you can start to see the differences here. So this is the C representing the coated stock. We just saw the uncoated stock in the number. But if you were hoping to get this bright purple, but you're printing on an uncoated stock, this is the color you're going to end up with. So again, look at the vibrance that you get between printing coated stock versus uncoated stock. Quite a difference here in these oranges, 151 in CMYK versus with the Pantone color. So something to definitely be aware of. I will caution you, Pantone color is expensive. So you don't necessarily want to have a lot of Pantones. In fact, you should probably only have one spot color. And oftentimes you'll find that will be perhaps a corporate color or a color that you're trying to match. So a hexachrome is a great way for printers to enhance the CMYK environment by adding an orange and a green hit, which means that they will add an orange tower and a green tower to get a vibrant color. So if they're printing flyers, right, can you imagine what the oranges and the reds would look like without having that extra pop? And that's where you can see that we have good pop with that color. So this would be a CMYK OG format for their printing. Now rich black. Rich black is interesting because when we're designing, the default in, say we're designing in Illustrator or InDesign, the default that we see is rich black. So our blacks look deep and rich. However, they may not print that way. And there's some cautions here. So if you have a layout, a poster, and the overall poster tone and feel is a little cool, so more blues in that feel, you may want to cool down your black. You don't necessarily want a warm black because it wouldn't balance properly. So by adding a little bit of cyan or a little more cyan to the black, it'll cool down the black. Vice versa, if you wanted to have your poster is full of reds and oranges, you might want to warm that up, warm the blacks up, and you would add a little more magenta to warm up your black. Now, Illustrator and InDesign, as mentioned, default to showing you rich black. You can change that by going into one of the settings in InDesign and in Illustrator under your preferences, and there is something that says rich black. Here you can see that when you would use a rich black or how consider rich black. So if you're just going to a plain toner, you're just black and white, it's just 100% black. Don't worry about creating a rich black. Commercial printing, that's where we want to start to look at a 50-50. This is a deeper black. A cool rich black is a 60-40-40, and a warm black is a 40-60-40. Now, if your printer says, oh, I'm going to make this a digital run, we're going to run this through our digital printers, you would still just maintain this as 100% black. Adding any depth to the colors ends up making it more muddy. But if you are on press on an offset or a commercial printing environment, then you're going to want to have and consider a rich black. This is the settings I was mentioning on how to change showing InDesign preferences, appearance of black. Display all blacks as rich black. This is your default. Change this over to actual black. Same thing here in Illustrator. Change it from rich black to a true black, so that you can see what the color looks like as you work with your files. Now, registration black, you'll see this in InDesign, and you can't delete it. My caution, never use it. It is meant for your registration marks. It's meant because if we've got cyan, magenta, yellow, and black, these plates, when you separate your files, will have to get married together. And they get married together using registration marks, and that ensures that they align properly. So this is combined of 100% cyan, 100% magenta, 100% yellow, and black. That's 400% ink. Think about if you had a black background on your poster and you use registration ink, right? That would really saturate the paper with that much ink on it. So not a good practice. Here's an example of some misregistration. So perhaps the plate was misaligned, but you can see the cyan and the yellow and the magenta, how it didn't quite align properly. Now, talking to that 400%, well, ink limits is a thing. You want to make sure that it's not going to compromise your paper. So printers will tell you what their ink limit is. So the values, you want to make sure that they set, and this is a base setting, so sheet fed offset on a coated stock or a coated paper is 320 to 340. Now we can change all of these settings inside InDesign's separation preview, and you can see your ink limits there. And we'll go through that exercise later. So sheet fed offset press, these are all the settings that you want to maintain. You can see that the offset in the uncoated stock is much lower because the ink is going to soak into the paper. So we've covered a lot in this module. We've talked about additive and subtractive, Pantone matching systems, rich black, and ink limits. Have a look back at the module and test your knowledge. See what you remember. Thanks.